Hello, children. I hope you're having a great day. I hope you're staying safe at home. So, today I will start with the theoretical portion of the study of gas laws. Okay, the numericals you've already completed. So, I thought we'd do the theoretical part in school once we get back, but I don't know when is that going to be. So, I thought let's start with the theoretical part. So, in the study of gas laws, we are basically talking about gases. So, when we talk about a gas, we are talking about the state of matter in which the interparticle attraction is very weak, okay, and the interparticle space is very large. So you know gases, they are very weak interparticle attraction between them, and the interparticle space between them is very large. So as a result, what happens? The particles are free to move in all possible directions in the entire space that is available to them. So gas occupies the entire space of the vessel in which it is kept, and in whatever type of vessel you keep it, it will take the shape of the vessels. And remember, all gases show uniform behavior, the same behavior under the same conditions of temperature and pressure, irrespective of what their chemical nature is, or what color they are, or what type of smell they have. Okay, now coming to the behavior and characteristic properties of gases. Now you know gases are composed of very small particles or molecules, and they are in constant motion. They keep on moving. Okay, so the kinetic theory explains the behavior and characteristic properties of gases. The first one is the composition of gases. Gases are made up of tiny particles or molecules which are in random motion. They are moving in all directions at all possible speed. The molecules are very small in size. Okay, now next is gases do not have a fixed volume, nor do they have a fixed shape. There is very less force of attraction between the particles, so the particles are free to move in all direction in all the space that is available to them. Okay, so if they are in a container, they cannot move beyond the walls of the container, so they will attain the shape of the vessel. Next is gases exert pressure in all directions. So you know the moving particles of gas, when they are moving in all directions, they will collide against each other, they will hit each other, and then if they are kept in a container, they will move towards the wall of the container, and again they will hit the wall of the container. So due to these collisions or hitting against each other or the walls of the container, the gas molecules exert pressure. Okay, and it has been found out that at a given temperature, time and area, the same number of molecules hit against the wall of the container. So gases exert the same pressure in all direction. Next, you know, gases are highly compressible. Why? Because they have large intermolecular spaces between them, so they can be brought very close together. That means they can be compressed together when pressure is applied. So as a result, so when they are brought together, what happens to the volume? The volume also decreases. Next, gases are also highly expansible. That means they can take up the entire space that is provided to them, and so they increase in volume when there is decrease in pressure and there is increase in temperature. So when pressure in a gas which is kept in a container is reduced, its particles move apart. That is, they occupy bigger space. So as a result, the intermolecular space also increases. So if the intermolecular space increases, the gas moves in all direction. What happens to the volume? The volume is also increasing. So if there is some gas, enclosed gas, it is heated, the kinetic energy of the molecules increases. Thus the molecule, they start moving faster and faster, and as they move faster and faster, they will hit against each other, and then they will move more far away from each other. So as a result, there is an increase in the volume of the gas. And another thing is number 6, gases have very low density. Again, the number of molecules per unit volume in a gas is very small, because again they have large intermolecular space between them, and they are very, very far apart from each other. So as a result, the density is very, very less. And then number 7 is gases have a tendency to mix with each other, which is known as diffusion. So when we talk about diffusion, we are talking about a process of mixing of two substances when they are kept in contact. And how do they mix together? By molecular motion, because the molecules of a gas are in constant motion. Now, for example, if you open a jar of chlorine or ammonia in a big room, you will get the smell, okay, in each and every part of the room. Although chlorine is heavier than air, it will not remain at the floor, but it spreads throughout the rooms, because the particles of chlorine which comes out from the jar, they will collide or hit against the air particles, and due to this collision or hitting against the particles of the air, they start moving in all directions. So this process will continue until there is equal concentration of chlorine particles inside the room. And next, gases can be liquefied. When we cool a gas, the kinetic energy of the molecules becomes very, very less. The particles will move very, very slowly, and when we apply a lot of pressure, the molecules come very, very close together. The intermolecular space gets reduced, and there is an increase in number of molecules per unit volume. Thus the gas turns into a liquid. Next, we come to molecular motion and relationship of temperature, pressure, and volume. Now, according to the kinetic model, the particles or molecules of a substance are always in constant motion. Since they are moving, they contain kinetic energy. Okay, all moving particles, they possess kinetic energy. Now, the average kinetic energy is directly proportional to the absolute temperature. That means if the temperature increases, the molecular motion also increases. And if the temperature decreases, then the molecular motion also decreases. That means if the temperature is 0, if it becomes 0, what will happen to the molecular motion? It will completely stop. So this fact is applied in defining a scale of temperature called the Kelvin scale. So when we talk about an absolute 0, we are talking about a temperature at which the molecular motion completely stops. Okay, it completely ceases on the Kelvin scale. So what are we talking about? We are talking about absolute 0. Okay, so what is absolute 0? Absolute 0 is the temperature at which the molecular motion completely ceases on the Kelvin scale. So absolute 0 or 0 Kelvin is equal to minus 273 degree Celsius. Supposing we have some gas enclosed in a vessel, you know that it will exert uniform pressure on all the 4 walls of the container. What is the reason? It is that the particles of the gas, they collide with each other and with the walls of the containing vessel. So the pressure is equally distributed on all the walls of the container. So the force exerted on a unit area of the wall of the vessel is equal to the pressure of the gas. Now supposing we increase the temperature of the gas by heating it, what will happen? Now we are keeping the volume constant here. Okay, the volume, we are keeping the gas in the very same container. The volume is same. So if we heat the gas, the kinetic energy of the gas molecules increasing. They start moving faster and faster in all directions. They will hit each other and they will hit the walls of the container with greater momentum. And the rate of collision of the particles also increases. Thus, the force which is exerted on the walls also increases. That means the pressure of the gas increases. Okay. Supposing if one of the walls of the container was movable because of the pressure, what would happen? This wall would move away, thus increasing the volume. So that means if there is increase in molecular motion, there will be an increase in pressure and the volume will also increase. Okay, so I'm going to do till here today. In the next upload, we are going to discuss the gas laws. So until then, children, stay safe, okay, and be good at home, help your parents, and God bless you.